Hey Raiders, here's a video just to kind of go over some of the basics about how you can graph equations when they're in slope-intercept form. I've already done another video that talks about what really is slope-intercept form of equations. And again, this isn't designed to kind of show you everything. This is just designed to go along with the lesson that's already in Odyseyware. So like always, if you have any questions, you can send me questions right in the help tabs of each problem in Odyseyware, or you can always get me on the Remind app. All right, here we go. So we're going to just graph several different y equals mx plus b slope-intercept form equations. And really there's just kind of two-step process. If slope-intercept generically is y equals mx plus b, and the m, the coefficient that's multiplied by the x, that's your slope. And in terms of graphing, we use the phrase rise over the run. That tells you when you make your graph, how much, when you go from one point to the next, how much do you have to rise up compared to how much do you have to run over to get to the next point. And then the constant, that's your y-intercept, and that shows where your graph hits the y-axis. So let's jump in here to some sample equations. Y equals 2/3 x plus 1. So if you look, this directly fits the y equals mx plus b format. So first things first, when you do these graphs, look at your constant. And you got to pay attention to the sign. It's plus 1. So the y-intercept is the plus 1. That tells you where your graph hits the y-axis. So here's the y-axis. Here's our origin. So here's 1. So you can put a point right there. So that's already a point in our graph. So we don't know at this point if which way the line goes, but we at least know it has to go through this point. Then the next part, take a look at the coefficient that's multiplied by the x. That's your m, or that's your slope. And again, the constant was the b. And this here's where we apply the rise over the run. So to get from this y-intercept point to the next point in the graph, rise over the run, we would rise up 2 and go over 3. And when we say over, it really means to the right. So from here, rise up 2, don't put a point there, but now we run over 3. So up 2, over 3, rise over run, 1, 2, 3. So that's really all you need to make your graph. It's never a bad idea to graph a third point, just in case you accidentally counted off by one number. Then you can see it's off, and then you can kind of just sketch a line that hits those points. And I can cheat here and just make my dots a little bigger and make it look like I hit them. All right, moving on to the next one. Y equals 3/4 x minus 2. This is why it's important to pay attention to the sign. Yes, the generic format of the equation is y equals mx plus b, but it really means you're just combining it with a constant, whether it's plus or minus. So in this case here, it's minus 2. So our y-intercept, here's 0. It's not up at positive. It's down 2. So that's the y-intercept. And now the coefficient that's multiplied by our x, by our independent variable, is 3/4. So our rise over run is 3 over 4. So from this point, so not from the origin, from this point, you're going to go up 3. 1, 2, 3. Don't put a point there. Now run over 4. 1, 2, 3, 4. Now we can just play connect the dots, and any point that's on this line will satisfy this equation. Okay, moving on. Y equals -1/2 x plus 3. So notice this is something a little different from the last two. Now we have a negative coefficient, so we'll address that in a second. First things first, graph your y-intercept, including the sign, so it's at plus 3. So here's the origin, so 1, 2, 3. Now, the negative sign, -1/2, it really doesn't matter if you attach it to the numerator or the denominator, but you only attach it to one spot. So let's attach it to the numerator. So in the previous examples, where we had positive coefficients of 2/3 and 3/4, our rise part, we went up 2 and up 3. Well, in this one here, apply that logic. Well, if it's the rise is -1, instead we're going to go down 1 and then over 2. And again, you could go down 1 over 2 again, just to give you a third point, just to further reinforce the fact that you did this correctly. So that's the big difference right there, is you attach the negative sign to either the numerator or the denominator. You don't attach it to both. Because if you attach it to both, and negative divided by negative would be a positive, and it wouldn't actually be a negative coefficient. Okay, so let's move on here. Now in this one, notice again, we have a negative coefficient in front of our x. So this time, just to change it up, I'll attach it to the denominator. But again, first things first, graph our y-intercept. Where does the graph cross the y-axis? Including the sign, it's at -4. So from the origin, go down 4. 1, 2, 3, 4. That's our y-intercept. And now, this coefficient, notice here, it's a whole number. That's the first time we've had a whole number. And if we're using this to do rise over the run to see how we get from one point in the graph to the next. How much do we have to rise up and how much do we have to rise over? Well, let's convert this to a fraction. -2 is the same thing as -2/1, so this becomes our rise over the run. So we can attach the negative sign to the numerator, or we can attach it to the denominator. It doesn't matter. So this time, let's attach it to the denominator. So from here, with a +2 for the numerator, for the rise, we're going to go up 2. But now, if the run, when it was positive, had always been to the right, well, now that it's -1, that's going to go to the left one. So up 2 to the left one, up 2 to the left one. That gives us our graph there. All right. Now, sometimes it looks like you don't even have a plus b part in y equals mx plus b, a y-intercept. Because if you look, it doesn't seem to fit y equals mx plus b. It does, it's just that it's +0. So our y-intercept happens to be right at the origin. So from there, now the coefficient in front of the x is 3. We'll put it in the rise over the run format as a fraction of 3/1. So we're going to go up 3, 1, 2, 3, over 1. And then just one more, just to give another example to kind of refer to. So identify your y-intercept. So in this case, it's +1. So at 1, we're going to put that y-intercept. And now the coefficient that's multiplied by our independent variable by the x, that's our slope, or the m, and y equals mx plus b. It's -1/4. Again, it does not matter where you attach the negative sign, either to the numerator or the denominator, but you don't attach it to both. So let's attach it to the numerator. So if your rise is -1, really means you're going down 1, and then to the right 4. 1, 2, 3, 4. There's that graph. All right, Raiders, if you have any questions, you can get me on the Remind app, or you can send me questions directly in Odyssey Aware. All right, take care.